Right now, as you're watching this video, there's a miracle happening in the soil beneath your feet. Plants are pulling nitrogen out of thin air and turning it into fertilizer. For free, forever, farmers spend over $60 billion every year buying nitrogen fertilizer. 60 billion, that's more than the GDP of many countries. And yet, there are plants that manufacture the exact same fertilizer themselves without a single dollar spent, without a single drop of fossil fuel burned. These aren't rare, exotic species. They're not genetically modified superplants from a laboratory. They're common plants that have been doing this for hundreds of millions of years. Your ancestors knew about them. Traditional farmers used them religiously. But somehow, in the rush toward industrial agriculture, we forgot, and that forgetting is costing us everything: our money, our soil, and possibly our future. This is the story of nature's most powerful fertilizer factory, the nitrogen-fixing plant. And by the end of this video, you'll understand why every single farmer, gardener, and homesteader should be growing these miracle workers. Because what I'm about to show you could revolutionize how we grow food. Let's start with a problem that most people don't even know exists. Nitrogen is everywhere. 78% of the air you're breathing right now is pure nitrogen. It's the most abundant element in our atmosphere. There's more nitrogen floating above 1 square foot of soil than that soil could ever need. But here's the cruel joke of nature. Plants can't use it. Nitrogen in the air exists as N22 nitrogen atoms bonded so tightly together that plants can't break them apart. It's like being surrounded by food you're starving. The food is right there, but you can't access it. Plants need nitrogen desperately. It's the main ingredient in chlorophyll, the molecule that lets them photosynthesize. It's essential for DNA, for proteins, for basically everything that makes a plant alive. Without nitrogen, plants can't grow, period. So we have this bizarre situation. The atmosphere is 78% nitrogen, plants are dying from nitrogen deficiency, and farmers are spending billions of dollars to solve a problem that shouldn't exist. This is where industrial agriculture came in with what seemed like a miracle solution. In 1909, a German chemist named Fritz Haber figured out how to break that N2 bond. He developed a process to pull nitrogen from the air and convert it into ammonia form plants can actually use. Another chemist, Carl Bosch, scaled it up for industrial production. The Haber-Bosch process changed everything. Suddenly, we could manufacture unlimited nitrogen fertilizer, crop yields exploded, the human population skyrocketed. Some estimates suggest that half the nitrogen in your body right now came from the Haber-Bosch process. Half the people alive today owe their existence to synthetic fertilizer. Fritz Haber won the Nobel Prize. He's been called the man who fed the world. But there's a darker side to this story. The Haber-Bosch process requires massive amounts of energy. We're talking about temperatures of 400 to 500 degrees Celsius and pressures of 200 atmospheres. It consumes between 1 and 2% of the world's entire energy supply. Every year, just to make fertilizer, that means burning fossil fuels, lots of them. The fertilizer industry is responsible for about 3% of global carbon emissions. To put that in perspective, that's more than the entire aviation industry. And it gets worse. When farmers apply synthetic nitrogen fertilizer, only about half of it actually gets absorbed by crops. The rest, it runs off into waterways, causing massive algae blooms that create dead zones in oceans and lakes. It seeps into groundwater, contaminating drinking water. It evaporates as nitrous oxide, a greenhouse gas 300 times more potent than carbon dioxide. We're spending billions of dollars burning massive amounts of fossil fuels and poisoning our water and air all to solve a problem that nature already solved hundreds of millions of years ago. Because here's what almost nobody talks about. There are plants that can pull nitrogen directly from the air, just like the Haber-Bosch process, but they do it at room temperature, with zero fossil fuels. And they actually improve the soil instead of degrading it. Nature has been running nitrogen factories for free since before dinosaurs existed, and we're just ignoring them. Let me take you back 350 million years, long before humans, before mammals, even before dinosaurs. The Earth looked completely different. The continents were arranged in unfamiliar shapes. The atmosphere had more oxygen. And in this ancient world, something revolutionary was happening in the soil. Certain bacteria had evolved a special enzyme called nitrogenase. This enzyme could do something almost magic-lit, could break apart that incredibly stronged and convert atmospheric nitrogen into ammonia. This was one of the most important evolutionary developments in the history of life on Earth, because suddenly, nitrogen, the limiting factor for all plant growth, was available. But these bacteria had a problem. The nitrogenase enzyme is incredibly sensitive to oxygen. Expose it to oxygen, and it stops working immediately. But they needed oxygen to survive. It's a biological catch-22. Then evolution did something brilliant. Some plants and these bacteria formed a partnership. The bacteria would live inside special structures on plant roots, protected from oxygen. In exchange for this safe house and some sugar from the plant, the bacteria would fix nitrogen and share it with their host. This partnership, this symbiosis, was so successful that it spread across the plant kingdom. Today, there are thousands of plant species that form these relationships with nitrogen-fixing bacteria. We call them legumes, and they've been running free fertilizer factories for over 300 million years. Every pea plant, every bean, every clover, alfalfa, vetch, and lentil, they're all hosting colonies of bacteria in their roots, pulling nitrogen from the air and converting it into fertilizer. And here's the beautiful part. They don't just feed themselves, they feed everything around them. When legume roots die and decompose, that nitrogen gets released into the soil. Other plants can use it. It's like having a fertilizer factory that works 24 hours a day, requires no input, costs nothing to operate, and improves soil health with every passing season. Traditional farmers understood this instinctively. For thousands of years, crop rotation always included legumes. The Romans planted beans between wheat crops. Medieval three-field rotation always included a year of clover or peas. Asian rice farmers planted soybeans. Native Americans planted beans alongside corn and squash, the famous Three Sisters. They didn't know about bacteria or nitrogenase enzymes. They just knew that growing legumes made the next crop grow better. The soil became richer, yields increased, it worked. Then industrial agriculture came along and told us we didn't need any of that old wisdom. Just buy fertilizer. It's more efficient, it's more reliable, it's modern, and we believed them. But was it really more efficient? Let's look at the numbers, because what I'm about to show you might shock you. A typical acre of soybeans, one of the most common fixing crops, can fix between 100 and 200 pounds of nitrogen per year. Some estimates go even higher. To put that in perspective, that's equivalent to about 200 to 400 pounds of synthetic fertilizer. At current prices, that's about $100 to $200 worth of fertilizer per acre per year for free. Now multiply that by the millions of acres farmers plant, the economic value is staggering. But here's what's even more interesting. Synthetic fertilizer is a one-time shot. You apply it, the plants use some of it, the rest washes away or evaporates, and next year you have to buy more. Nitrogen-fixing plants keep working year after year. The bacteria in their roots are constantly pulling nitrogen from the air. When the plant dies, that nitrogen stays in the soil. Other plants use it. When they die, their organic matter feeds more bacteria, which fix more nitrogen. It's a self-sustaining cycle. Traditional farmers in many parts of the world still maintain soil fertility entirely through nitrogen-fixing plants. No synthetic fertilizer at all. And they've been doing it for generations, sometimes centuries, on the same land. There are documented cases of farmers in India maintaining the same fields for over 1,000 years without synthetic inputs, just by rotating with legumes. Compare that to industrial agriculture, where soil degradation is so severe that some scientists estimate we only have 60 years of topsoil left if current practices continue. 60 years, that's within the lifetime of people watching this video right now. So why aren't more farmers using nitrogen-fixing plants? If they're so effective, so economical, so sustainable, why hasn't every farm adopted them? The answer is complicated, and it reveals a lot about how modern agriculture actually works. First, let's be honest. Synthetic fertilizer is incredibly convenient. You buy a bag, you spread it on your field, and boom, instant nitrogen. You don't have to wait for plants to grow. You don't have to till them under as green manure. You don't have to manage crop rotations. It's fast, it's simple, and it fits perfectly into monoculture farming systems. Monoculture, growing the same crop on the same land year after years, the foundation of industrial agriculture. It allows farmers to specialize. They can buy equipment specifically for one crop. They can develop expertise in growing that one crop. They can negotiate better prices for selling large quantities of one crop. But monoculture requires massive fertilizer inputs because you're growing the same nutrient-hungry crop repeatedly without giving soil time to recover. Nitrogen-fixing plants require diversity. They require rotation. They require thinking about your farm as an ecosystem, not a factory. And many farmers, especially large industrial operations, simply aren't set up for that. There's also an economic pressure that most people don't understand. Many farmers don't own their land, they lease it on short-term contracts. Why would you invest in building soil health if you might not be farming that land next year? Why plant a nitrogen-fixing cover crop that takes time to decompose when you could just spray fertilizer and plant your cash crop immediately? The incentive structure of modern agriculture rewards short-term thinking. And then there's the fertilizer industry itself. This is a multi-billion-dollar industry with enormous political influence. They fund agricultural research, they sponsor university programs, they advertise heavily. They've convinced multiple generations of farmers that synthetic fertilizer is not just convenient but necessary. I'm not saying there's some conspiracy. I'm saying that economic systems tend to perpetuate themselves. When billions of dollars depend on farmers buying fertilizer every year, there's very little incentive to promote alternatives. But here's what's changing: the cost. Fertilizer prices have been incredibly volatile in recent years. In 2021 and 2022, prices more than doubled in many markets. Farmers who were spending $50,000 on fertilizer suddenly faced bills of $100,000 or more. That got people's attention. Suddenly, nitrogen-fixing plants don't look like some hippie alternative farming method. They look like a serious economic strategy. They look like insurance against price shocks. They look like a way to reduce dependence on external inputs. And farmers are noticing something else. The synthetic fertilizer treadmill is getting faster. Here's a pattern that plays out on farms around the world. You apply synthetic nitrogen fertilizer. Your crops grow great that first year, but over time, you notice you need more fertilizer to get the same results, so you apply more, which kills more soil microbes. Which means you need even more fertilizer the next year. It's a vicious cycle. The more synthetic fertilizer you use, the more dependent you become on it, because you're destroying the biological systems that naturally cycle nitrogen. Soil scientists call this the fertilizer treadmill, and it's one of the most serious problems in modern agriculture. Meanwhile, farmers who incorporate nitrogen-fixing plants into their rotations report the opposite pattern. Over time, they need less fertilizer, not more. Their soil becomes more fertile, more biologically active, better at holding nutrients and water. Studies have documented this phenomenon repeatedly. Fields managed with legume rotations show higher organic matter, better soil structure, more earthworms, more beneficial fungi, and more microbial diversity. All of that adds up to healthier plants, which are more resistant to pests and diseases, which means less need for pesticides, which means lower costs and higher profits. But you have to think long-term. You have to see your soil as a living system, not an inert medium for holding up plants while you pour chemicals on them. And that's a fundamentally different way of thinking about agriculture. Let me show you what this looks like in practice, because the best way to understand nitrogen-fixing plants is to see them working. There's a farmer I know in the Midwest who was spending over $60,000 a year on fertilizer for his corn and soybean operation. $60,000. Every single year, about 10 years ago, he started experimenting with cover crops. During the winter, when his fields would normally sit bare, he started planting a mix of nitrogen-fixing plants, mostly clover and vetch, with some radishes and turnips mixed in. The first year, he was skeptical. The cover crop cost about $20 per acre to plant. Across his farm, that was about $8,000. But he figured it was worth trying. In spring, he tilled the cover crop under and planted his corn as usual. He reduced his fertilizer application by about a third, just to see what would happen. The corn grew just fine. In fact, it looked healthier than usual. The stalks were thicker, the color was deeper green, and at harvest, his yields were actually slightly higher than the previous year. He ran the numbers. He'd spent $8,000 on cover crop seed but saved $20,000 on fertilizer. Net benefit, $12,000. The next year, he expanded the program, more acres in cover crops, less synthetic fertilizer, the same results: good yields, healthy plants, and significant cost savings. By year 5, he'd cut his fertilizer costs by more than half. $30,000 saved annually. And his soil tests showed something remarkable. Organic matter was increasing. Nitrogen levels were stable, even with less fertilizer input. His soil was actually getting better. By year 10, he was spending about $15,000 on fertilizer, a quarter of what he used to spend. His cover crop costs had dropped to about $5,000 because he was saving and replanting his own seed. Net savings, $40,000 per year. Over 10 years, he saved $400,000. And his soil was in the best condition it had been in decades. This isn't a fairy tale. This is documented in his farm records. I've seen his soil tests, I've walked his fields, and he's not unique. There are farmers all over the world discovering the same thing. Nitrogen-fixing plants work. They save money. They improve soil. And once you figure out how to integrate them into your system, they're actually less work than constantly buying and applying synthetic fertilizer. So what are these miracle plants? And how can you use them? Let's start with the most common family, legumes. Legumes include everything from tiny clovers to massive trees. The family has over 19,000 species, and most of them can fix nitrogen to some degree. For agriculture, the most important ones are soybeans, probably the most widely planted nitrogen-fixing crop in the world. They're primarily grown for food and oil, but they're also excellent at fixing nitrogen, typically 100 to 200 pounds per acre per year. Alfalfa. This deep-rooted perennial is one of the most productive nitrogen fixers, capable of fixing over 200 pounds per acre annually. It's primarily used as livestock feed, but some farmers grow it specifically as a green manure to build soil. Clovers. There are many species: red clover, white clover, crimson clover, sweet clover, and they're all excellent nitrogen fixers. Clovers are perfect for cover crops because they grow quickly, provide dense ground cover, and their roots die off easily, releasing nitrogen for the next crop. Field peas, fast-growing annuals that can fix 60 to 100 pounds of nitrogen per acre in a single season. They're often planted as a spring cover crop before warm season vegetables. Vetch, particularly hairy vetch. This is a cold-hardy cover crop that can fix massive amounts of nitrogen, up to 200 pounds per acre. It's a favorite among organic farmers because it provides excellent weed suppression and soil building. Cowpeas, heat-loving legumes that thrive in conditions where other cover crops struggle. They're popular in the southern United States and tropical regions. Fava beans, cool-season legumes that can be grown over winter in mild climates. They fix nitrogen and produce an edible crop double benefit. Lentils, chickpeas, peanuts, basically every bean you've ever eaten comes from a nitrogen-fixing plant. But here's what most people don't know. Legumes aren't the only nitrogen fixers. There's another group of plants called actinorhizal plants. They form symbiotic relationships with a different type of bacteria called Fungia. These include alder trees, Russian olive, sea buckthorn, and several other woody species. These trees can fix even more nitrogen than legumes. Some estimates suggest over 300 pounds per acre per year, and because they're perennial, they keep fixing nitrogen year after year without replanting. Imagine a farm with nitrogen-fixing trees planted in hedgerows around the edges. Those trees are pulling nitrogen from the air constantly. Their leaves fall and fertilize the soil. Their roots go deep and bring up minerals from subsoil, and they provide windbreaks and habitat for beneficial insects. This is called agroforestry, and it's one of the most promising approaches to sustainable agriculture. But it requires thinking about your farm as a long-term ecological system, not just a production facility for this year's crop. Now, here's the practical question. How do you actually use these plants? Nitrogen is 78% of the air. Plants exist that can capture it for free. They cost less than fertilizer. They improve soil instead of degrading it. They reduce pollution. And they're proven to work. We're not using them widely because we're stuck in an outdated system, But that system is changing. Every bag of fertilizer you don't buy is money saved. Every nitrogen-fixing plant is working for you constantly, pulling nitrogen from air and building your soil. Nature solved this problem 300 million years ago. We just forgot. So here's my challenge. This season, try it. One bed, one field. Plant nitrogen-fixing plants. Watch them work. Then plant your crop with less fertilizer. Document everything. I think you'll be amazed. The best fertilizer isn't made in factories. It's grown in your soil. By plants that have perfected the process since before humans existed. Free fertilizer, forever. That's not too good to be true. That's just nature doing what it does best.